Yo, 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 yo. Hey, everybody. This is Mr. G, and we're going to talk about linear functions. So there's going to be a lot of vocabulary terms in this and a lot of details. Not a lot of actual math. It's more just talking about what makes a linear function and like different pieces of functions. And we're going to use these terms for functions all school year. So these are pretty important. So we'll get into all of these key terms throughout the slide instead of going over all of them right now. The biggest thing right now is function, domain, and range. That's what we're going to talk about first. So, functions. The way we know something is a function or is not a function is basically if each input is assigned to exactly one output. So, what functions are is they are made of a bunch of inputs, and then those inputs create an output. So, the inputs are always going to be your x values. The outputs are always going to be your y values. So by input, we're saying the input is what determines the output. And then if it's a function, then what it is the functions, we plug in our inputs. We have some type of rule. So for example, for linear functions, our rule is y equals mx plus b. It's slope-intercept form, and it's an equation it's an equation of a line. So then I would plug in my x, which is my input, and then I would do some math, and then out comes the y value, which creates the ordered pair that is on that particular line. So every input for a function has exactly one output. That means if I were to plug in 1 into this equation, then the same y would come out each and every single time. Okay, now an example of something that wouldn't be a function then is if I had 1 multiple times. I have the same input multiple times, and one time it comes out 11, another time it comes out 12. Maybe I plug in 1 again, it comes out 11. This is not a function. That means it's not following a rule. If I had an equation that was the rule for this function, if I had an equation that was a rule for this particular function, then every time I put in x for an input, or 1 for an input, I should get the exact same output each time. Because if you do the math, that means you're going to get the same result each and every single time. But as soon as I get a different output, it's no longer a function, because that means it doesn't have an equation that it's just following. So this doesn't have a particular rule. This is some weird stuff going on, and this would not be a function. So this one right here, though, is a function. And the reason why it is a function is because each one of these inputs just have one output. Now, 3, 4, and 5 have the same output, but that's fine, because every time I put in 3 I get 13, every time I put in 4 I get 13, every time I put in 5 I get 13. So as soon as you look at your inputs, as long as you have different inputs, it's automatically going to be a function. If you have the same output, that doesn't really determine anything. We have to look at our inputs first. So each and every single one, like the input of 1 has one output. The input of 2 has its own output. The input of 3 has one output. The input of 4 has one output. The input of 5 has one output. So it is a function. Now, domain and range. Domain are all the possible x values of a function. So the domain of this function are all the x values, 1, 2, 3, 4, 5. Because those are all the x values. Those are all the inputs. Range are all the y values, 11, 12, 13, and that's it. So these are my domain is all the x values. Range is all of the y values. And that's it. Now, functions can also model situations. So sometimes you're going to have to figure out a reasonable domain and a reasonable range for a certain situation. So the domain is all the possible inputs. So for this particular function, my domain was all the x values, all the things I'm going to input, and the output is the range, everything that comes out as a result of that input. Okay, so for a word problem, so if I want to know a reasonable domain and range, if we look here, a hose fills a 10,000 gallon swimming pool at a rate of 10 gallons per minute. So I have a swimming pool, and we're filling it up with a hose. It fills up 10 gallons per minute, and we need to go 10,000 gallons. So the input and the output are what I'm trying to figure out here. Okay, so the input is going to be what comes first to determine the output. So the amount of time that this hose fills up the pool is going to determine how many gallons of water are actually going to be in the pool. I mean, the amount of time we have the hose going is what's going to determine how much water is actually in the pool. So my input, or my X values, or my input, which is also just my domain, all of these are the same. So my X values, which is my inputs, which is my domain. So my domain is number of minutes. Okay, is the number of minutes to fill up the pool. Okay. And I apologize, my pen's not working. I'm having issues, so I got to do this all with the mouse. So that's why it's pretty ugly. Not that it's ever that pretty anyways. So my X, my input, my domain is the number of minutes to fill the pool. So the minutes are going to determine how much water are in the pool. So the range, now the range though, the reasonable range is going to be 0 to 10,000. So the reason why it's 0 to 10,000 is because the pool is only 10,000 gallons, right? So the range, depending on how many minutes, I could start, if I have 0 minutes, I'm going to have 0 gallons of water in the pool. But as soon as we get to 10,000 gallons, we're going to stop the hose. So I'm not going to be able to fill it more than 10,000 because that's the max I can put in this swimming pool. So the range has to be anywhere from 0 to 10,000, but it will stop at 10,000. And those are all the possible outputs. So depending on how many number of minutes I can put, it's going to be really any number between 0 and whatever the max amount of minutes it takes to fill it in this pool. So try the second one. Go ahead and pause it, see how you do, and try to do this second one right here and fill out a reasonable domain in a reasonable range. Okay. So again, domain is input. The X value is what's going to determine the output. So here's what I got. So for this one, a reasonable domain is from 0 tables to the number of tables that are needed. Okay, the amount of tables is what's going to come first, and then after that, once we figure out how many tables we need, then we're going to figure out, okay, cool, and then each table gets 4 chairs. So a reasonable range is multiples of 4 from 0 to the number of tables needed, because we're not going to put just 2 tables at a chair. 2 chairs at a table. So the reasonable range would be like 4, 8, 12, because depending on how many tables I have, that's going to determine how many chairs I have. But it's going to be in multiples of 4. Okay, and that's it. So these ones take practice, so don't stress about these too much. And one of the last things we're going to talk about today is whether or not something is discrete or continuous. So I want to actually look at the chairs and the pool. Okay, while these two functions don't necessarily match these two graphs, the idea is still the same. So let's say we're filling up a swimming pool, right? And let's pretend that this line started here at 0, because the pool would start at 0, 0, and then it would start filling up and up and up. This is going to be what's called a continuous function. And the reason why it's continuous is because it is possible to fill up this swimming pool. This was a swimming pool. It is possible to fill it up for 1.5 minutes. We're allowed to have values. The values in between the perfect points are still going to be relevant. Okay? They're relevant because you could fill up the pool anywhere between 1 minute and 2 minutes and 3 minutes. You could have 1 minute and 15 seconds, 1 minute and 16 seconds, which means you're not going to have just 10 gallons every minute. You might have 10.5 gallons at one point, 10.6 gallons at one point, 27.8 gallons at one point. So what that means is all of these points are connected and they make a straight line. And that means all the values in between, like these perfect points, like this is a perfect point, and I don't see any other perfect points, to be honest with you. But all the values in between the perfect points are still relevant and still count. So that would be a continuous function. A discrete function, a function is discrete when everything in between doesn't work for the scenario or doesn't work for the situation. This would be an example of the tables and chairs. And again, this graph does not match the tables and chairs, but the idea is the same. Okay, so if we had, let's say we knew X represented the amount of tables because that was our input, right? And Y represented the amount of chairs. So if I had 1 table, we knew that meant we were going to have 4 chairs. Well, I'm not going to have half a table. So that this point in between here and here doesn't make any sense. Okay, so I'm not going to have half a table, and I'm not going to have half the chairs. I'm either going to have one table, 4 chairs, and then I might have 2 tables, 8 chairs. So everything in between these two is irrelevant. So that's why we're not connecting those points. We're not connecting them, which means this is a discrete function where we're only using the whole numbers and the integers because that's the only thing that's relevant for the situation. So continuous functions make a straight line and everything in between, all the points, all the real numbers in between the perfect points are relevant. Discrete is when we're just a series of points on a graph where only whole numbers and integers are relevant and the decimals and the fractions in between do not matter. They're not relevant. Okay, here's what I want you to do. I want you to pause it and find the domain and range of each one of these functions and then go ahead and unpause and check to see how you did. So now we're going to start practicing. Okay, so your domain was just a list of all the x values, all of your inputs, and your range was just a list of all of your y values or all your outputs. So I put 7 on here twice, and I probably shouldn't have even done that because it's really just 7's part of my range. It doesn't need to be on there twice. There's no reason for that because once it's on there, it's on there. It's a possible output. And then here's my possible x values, my possible y values. Okay, so that's it for domain and range. All right, and we know that these are a function. This is a function because each one of these, I don't have a repeated input on here. I don't have a repeated input, so it's automatically a function. So sometimes you'll see this is in a different notation, but these are just ordered pairs. These are just ordered pairs. So we want to see if it's a function or not a function. So if I look at all my ordered pairs, so look at all the x values first, and look to see, do you have an x value that repeats itself at all? And the answer is no, I don't. So yes, it is a function. Okay. If I look here, do I have an x value that is the same? All of these x's are different. So yes, it is a function. Now what we want to look at is to see, okay, well, if it's a function, is it 1-to-1 or is it many-to-1? Okay. So what that means is 1-to-1 just means that each output, it only happens one time. Like we don't have a repeated output. So, for example, if I look, my outputs now are 7, 5, 4, -8, -11, no repeats. So it's a 1-to-1. Every x has its own individual unique output. If I look at this one, if I look at for any repeats here, 8, 4, 1, 4, 8. So the 4s and the 8s are repeats. So that means it's many-to-1. That means there's multiple inputs. I have 2 different inputs that go to the same output. That's why many inputs go to one output. So this is how many inputs will go to the same output. This is just one input to every one output. This one is multiple inputs go to only one output because I have 2 different x's, 2 different inputs that go to the same output of 8. Okay. Same thing here. This is just your x values. These are just your y values. So again, this is just another way of writing out your points. And so this is one where we look at it and say, is it a function, yes or no? So I look at all my inputs and see, does it go directly to one output? Well, if we look at this 2, this goes to 1. -2 goes to 1, so that would be a point right there. But then -2 also goes to 3. So right away, I can stop here. It's not a function. Okay, this would be an example of not a function because my input, I have one input that goes to 2 separate outputs. And that means it's not following the same rule because if it was a function, it would follow the same rule each time, which means that every time I plug this into the rule, then it would have to get the same answer each time. And if it's getting a different answer, that means there's not really a rule. So not a function. And then finally, if you look at a graph, one trick we can do when looking at a graph is what's called the vertical line test. So if I want to determine, is this a function? So I'm looking at this graph right here, and I'm like, hey, is this graph a function? Well, the way I figure that out is we can do what's called the vertical line test. And yeah, you guys might not have a vertical digital screen with a line on it, but you guys have a pencil, and a pencil can make a vertical line. What we do is, because the definition of a function is that each input has to have exactly one output, right? It can't be the same. Well, if I look, all my inputs are x, right? So that means as long as this graph only crosses this line one time on the vertical line, it's automatically, that means each x value only has one y value. Okay, so if I take this here, this graph is only crossing this vertical line one time. That means this input right here only has one possible output. This x input here, I'm sorry, I'm trying to grab this, there we go. This x here only crosses this line right here one time. So that means the input when x is this value right here, which is -6, the output is right here. And that's how we determine that it is a function. I'm going to take my pencil, go across the graph. Oh, it only crosses at one time, one time, one time, one time. It's automatically a function. Now, an example of a graph that wouldn't look like a function, I'm just going to draw over here real quick. So let's say I drew a C. I know I'm drawing over the same graph and I apologize, but let's say this C was my only graph. Well, if I take my vertical line, you see how this graph crosses it here and here? That means when x is 2, this is -2, right? So when x is -2, it has a y value here and a y value here. That means -2, that'd be like this one right here, where it's going to two different spots. This is not a function, because that means if I plug in x, I get two different y's, and that's not possible. Excuse me, that's not possible. So this vertical line test helps us determine if it has multiple outputs or not. Okay. All right, so yes, this is a function. My original graph, it is a function, and it is many to 1. And the reason why it's many to 1 is because if you notice here, and let me just do some erasing so we can get back to what we're looking at here. If we notice, like for the y values, I have a y value of 0 here, and I have a y value of 0 here. So that means when x is -6, y is 0. When x is 0, y is 0. So there's the same output twice, which is fine. That's okay. It's still a function. It means that this is a function that we're going to learn later on. But it's still a function. It's still following a rule. But that means I have the same output twice, so it's many to 1. We just talked about the vertical line test. So what I want you to do is I want you to, oh no, never mind. Let's talk about number 8 together. So last thing we're going to talk about are constraints to a domain of a function. So the word constraints means what limitations are there? What are the limitations of the domain? So what's going to prevent you from using certain values as your input? So here's what I mean. Fiona buys different amounts of gas at $2.25. She has a graph which shows the different amounts she should pay. Okay. So she's paying $2.25 amount per gas, and maybe she only has $10 or $15. The amount of gas, the amount of money she has is going to be different based on how much gas she buys. But the biggest thing is it possible to have a negative domain here? Is it possible for her to buy negative gallons of gas? Because the gallons of gas is their domain. Okay, the amount of gas she buys. And she's paying $2.25. So the amount of gas she buys is going to determine how much money she pays. So the thing is that she has to start at 0 and work her way up. It is impossible for the domain the domain has to be greater than 0. So that would be a constraint. It means the domain can't be less than 0. So I'm saying, what's the limitation? What's a restriction on this domain? Well, it can't be less than 0. And the reason why is because it's impossible to buy negative amounts of gas. So that would be a constraint to this domain. And then after that, she can buy as much gas as she wants to. She can buy 1.5 gallons of gas, 1.25. So all the real numbers in between each whole number still counts, but it just can't be a negative number. Okay, because it's impossible to buy a negative amount of gas. So that would be a constraint to the domain. Okay, a lot of information in this one. It's going to take some practice. It's going to take some questions if you have confusions, and it's going to take some studying and looking at these terms and understanding what they all mean. So, independent practice, things to remember. If you guys have any questions, let me know. Critias out.